Okay, hello everyone, and now next subject.
What it means to be a prime number. And what you'll see in this video, or what you'll hopefully see in this video, is it's a pretty straightforward concept, but as you progress through your mathematical careers, you'll see that there's actually fairly sophisticated concepts that can be built on top of the idea of a prime number. And that includes the idea of cryptography, and maybe some of the encryption that your computer uses right now could be based on prime numbers. If you don't know what encryption means, don't have to worry about it right now. Just need to know that prime numbers are pretty important. So I'll give you a definition, and the definition might be a little confusing, but when we see it with examples, it should hopefully be pretty straightforward. So a number is prime if it is a natural number, and a natural number, once again, just as an example, these are like the numbers 1, 2, 3. So essentially the counting numbers starting at 1, or you could say the positive integers. It is a natural number divisible by exactly two numbers, or two other natural numbers. Actually, I shouldn't say two other, I should say two natural numbers. So it's not two other natural numbers, divisible by exactly two natural numbers. One of those numbers is itself, and the other one is 1. Those are the two numbers that it is divisible by, and that's why I didn't want to say exactly two other natural numbers, because one of the numbers is itself. And if this doesn't make sense for you, let's just do some examples here and figure out if numbers are prime or not. So let's start with the smallest natural number, the number 1. So you might say, well, look, 1 is divisible by 1, and it is divisible by itself. You might say, hey, 1 is a prime number. But remember, part of our definition, it needs to be divisible by exactly two natural numbers. 1 is divisible by only one natural number, only by 1. So 1, although it might be a little counterintuitive, is not prime. Let's move on to 2. So 2 is divisible by 1 and by 2, and not by any other natural numbers. So it seems to meet our constraint. It has it's divisible by exactly two natural numbers, itself, that's 2 right there, and 1. So 2 is prime. And I'll circle the prime numbers. I'll circle them. Well, actually, let me do it in a different color since I already used that color for the. Well, I'll just circle them. I'll circle the numbers that are prime. Now let's 3. And 2 is interesting because it is the only even number that is prime. If you think about it, any other even number is also going to be divisible by 2, above and beyond 1 and itself, so it won't be prime. We'll think about that more in future videos. Let's try out 3. Well, 3 is definitely divisible by 1 and 3, and it's really not divisible by anything in between. It's not divisible by 2, so 3 exactly divisible by 4. You could divide them into here, and then maybe I'll try out for yourself if 51 is. We can give you some practice on that in future videos or maybe some of our exercises. Determine whether the following numbers are prime, composite, or neither. So just as a bit of review, a prime number is a natural number, so one of the counting numbers, 1, 2, 3, 4, 5, 6, so on and so forth, that has exactly two factors. So its factors are 1 and itself. 1 and itself. So an example of a prime factor is 3. There's only two natural numbers that are divisible into 3. 1 and 3. Or another way to think about it is the only way to get 3 as a product of other natural numbers is 1 times 3. So it only has 1 and itself. A composite number is a natural number that has more than just 1 and itself as factors, and we'll see examples of that. And neither, we'll see an interesting case of that in this problem. So first, let's think about 24. So let's think about all of the, I guess you could think of it as we get to 17, 3, 4, 5, 6, 7 is once again 17 is prime.
Wait, why is neither? Why is one neither?
has 2. Every other even number other than 2 is not prime, technically, because it is not, it only has 1. It only has 1 as a factor. It does not have 2 factors. 1 is itself,
Okay,
but in
yeah.
order to be prime, you have to have exactly 2. It has exactly.
No. Okay, let's review factors. Factors are whole numbers that can be divided into factors. What? Learn about prime factors. Why are we reviewing practice when we're talking about prime and okay? 1 and 15 are factors of 15. Which of the following factors of 1, 2, no, yeah? It's a prime number. Yes. No, wait. Yeah, it is. It's a composite number. Yo, what? Oh, okay, let's go. Shows only multiples of 12. Which of the following shows only multiple? Chill. Okay, another. Which of the following best shows multiple for 8? Oh, wait, is it not? 70. Oh, yeah, 76 it is. What's the multiple of 65? No, I don't want bonus questions. Skip. Actually, no. Which of the following numbers is of 7? Bro, what? I swear. Yeah, I've done this. Wait, whoa. Basically, the trick is a prime can be created, can't be created. Basically, it's unnatural. Ah, wait, is it? No, it can't be that. It can't be 71. It can't be 33. It can't be 25. It is 36. Oh no, it's not because. Oh. Well, it's not this. It's not six. Is it? No. It's in the 4 times tables. Because 20 is in the 4 times tables. And if you do 20, so let's go from 60. Yeah. Well, it's not 25. Yeah, it's not 33. Wait, it can't be. Yes, you can create it. Oh, I was thinking of kind of the wrong thing, but no, you can. 8 times 9. Yes. Yes, bro. Isn't 8 times 9 70? Calculator. 8 times 9. 72. I'm dumb. Never mind. Which of these numbers is prime? Composite number is something that can be created. I'm pretty sure. Yep. This can be created. This can be easily created. So, oh no, wait. 4. 27. Ooh. 99. No, skip the bonus, please. Okay, no. Which number's composite 25? Four questions. Is each 70? It is probably composite. Let me think. Yeah, it is composite. Try to shade any prime numbers on the Oh yeah, right bad. Um, think, yeah. Wait, another one, bruh. Oh. Um, oh my god, I'm so lazy to do this. Man, I literally did this. I did it. I'll just tick these stuff to know that I...
Right? The
Okay, goodbye.